Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on MinStack. It's same as solving any other problem on stack. The only complicated part is that we have to perform all the operations push, pop, top, get, min in O of 1 time complexity. Okay, so let's jump into the problem statement, understand it and start solving. Last time we have solved the product of array except self. You can find it in the list. Let's start with MinStack. Okay, let's go through the question quickly. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Here the constant time means O of 1. Implement the MinStack class. MinStack initializes the stack object. Okay. Push pushes the element. Okay. Pop removes the element. Top gets the top of the element, and getMin retrieves the minimum element. You must implement a solution with O of 1 time complexity. Now the problem statement is quite simple. Only thing is, let's say, so before even understanding it with examples or trying to solve it any other way, let's look at the methods that we have to implement. There is one is MinStack. Here we just have to initialize our stack. Push, we simply have to push the element to the stack. Pop, we have to pop. Top, we have to tell which element is at the top, so we'll do a quick peek, right? Now the problem is that how will we get the minimum element every time, right? Because that is the only concerning point for us. Rest all the methods we know how to solve them, but to get the min element, let me tell you why that is a problem. Okay, let's say we have numbers like this: 2 3 1 4 6. Okay, if I have to from this stage, suppose I have inserted them in the stack, so 2 is at the bottom, 6 at the top. How can I return the minimum element? Minimum element is 1, right? How can I return that minimum element in time complexity of O of 1? I can return the minimum element, but returning it in O of 1 time complexity is quite tricky. Okay, so I would suggest to take a minute, think of a approach, and let's start. Ready? Okay, so what I am suggesting is, what we can do is we can use two stacks actually. So we'll use one main stack, okay, where we'll perform the operations push, pop, top, min stack, get pin, everything. And then we'll have another stack. We'll call it, let's say we have another auxiliary stack or the temporary stack. We'll call it min stack. And we will keep the minimum element at the top of this stack. So every time when we have to return the minimum element, we'll directly return it from the top of the stack. Okay, let's jump into the implementation. This is very pretty easy problem statement. Once we go through the code, you'll realize it. Okay, so let's initialize our stacks. So I'll say main stack to store elements. Okay, so we can say private stack integer stack. Similarly, we need a temporary stack, or let's call it auxiliary stack actually. So we need auxiliary stack to keep track of the minimum element at each level. Okay, now what do I mean by at each level? So as per this example, right, that we had written earlier, if you write anything 2 1 4 5 0 8, at this level when we had only one number, 2 was the minimum. At this level 1 is the minimum. At this level 1 is the minimum. At this level 1 is the minimum. At this level 0 is the minimum, and at this level 0 is the minimum. So at each level we'll save the minimum at the top of this auxiliary stack, right? So we can say private stack integer, let's call it min stack. That's it. Okay, so we have initialized our two stacks. Now what are we going to do in MinStack? We are just going to initialize them, right? So stack is equal to new stack, that's it, and MinStack is equal to new stack, that's it. Now what are we going to do in push? We are going to push the elements, right? So we have to push the element to our main stack, as well as we have to keep track of the minimum, right? So we can say push the element onto the main stack. So we can say stack dot push value. Simple, right? Similarly, now we want to keep track of the minimum element. So if this new value is smaller than the previously stored top element in our min stack, we'll update it. Okay, so we'll check, update the minimum element in the min stack, right? So we'll check if min stack dot is empty. So first time it will be empty, so we need an empty check as well, or value, that is the value that we are currently receiving, is less than equal to MinStack dot peak. We'll check the top element. If it so happens, that means if the MinStack was already empty, this value will be the minimum. If the MinStack is not empty, but the value at the top of the MinStack is bigger than this value, then we'll update the top value with this one, right? So we'll just push this value to the stack so that it will be on top of the min stack. So we can say min stack dot push value. That's it. That's all we need, right? Push is generic operation, and for keeping the minimum at the top, we are doing this operation. Similarly, for pop, we want to return the top of the element, right? So we can say pop the element from the main stack. So we'll say int popped is equal to stack dot pop. Now we only have to return void, so we do not have to return anything. Why to take it inside an integer, right? Because let's say we remove the element from the stack, but that element also happened to be our minimum. So let's say from this one we were removing 8 was removed, then we removed 0. Now 0 is our minimum element right now, right? So if 0 is getting removed from the main stack, it must be removed from the minimum stack as well, right? When we were removing 8, we didn't remove 0, but when we are removing 0, we need to remove 0 from the min stack as well. So where are we? We are at the pop. Okay, so we'll check if the popped element is the minimum, that means it's at the top of the stack. Update the min stack, right? So we'll check if pop is equal to min stack dot peak. That means that is the minimum min stack top element, right? So we'll simply remove it from the min stack as well. Min stack dot pop. That's it, right? Yeah, as you can see, I still have cold. Okay, so this is the generic operation for removing the top element. We do a stack dot pop, and since we want to maintain the min element as well, we are checking if the top element was part of the min stack. We remove it from the min stack also. Now the third is top. What does top do? It is just going to peek at the top element, right? We don't have to remove anything, so we don't have to update the min stack as well. So we can say return the top element of the main stack. So we can say return stack dot peek. We are not going to remove it. We'll just peek and return. Now getMin. Now this is the main method for which we actually kept a min stack, right? So we can actually return the top element from our min stack, and that will be the minimum element. So we can simply say return the minimum element from the min stack. Since that is at the top of the min stack, we can say return min stack dot peek. We're not removing the element, we're returning the top element here. Okay, that's it. That is all in this problem statement. And if you notice, Now all of these operations, push, pop, top and getMin, are in time complexity O of 1, right? Let's run it, since that was the asked in the question. Okay, it's working fine for the test cases. Let's submit. Great, it's working fine, right? Beat 62.69%. That means there does exist a approach which is faster than this one. Now I did try, but I could not think of any better approach than this one. But if you guys know, please let me know in the comment section. I'll be happy to check that up, right? So that's all from today's video, everyone. If you have anything, please let me know in the comment section, and at the end, please like, share and subscribe. Thank you.